The world is constantly evolving, and to keep up with our ever-changing needs and desires, massive construction projects are being undertaken across the globe. These ventures are amazing in their scale and complexity, so for today's video, I'm counting down the top 15 most massive construction projects in the world. Starting with number 15, the Bosco Verticali. Growing within Milan's Porta Nuova district, the Bosco Verticali, or vertical forest, is a groundbreaking marriage of sustainable urban design and architecture. In 2015, Italian architect Stefano Boeri, along with Boeri Studios' Gianandrea Barreca and Giovanni Lavara, brought to life this visionary project, comprising of two towers soaring at heights of 260 and 360 feet. Adorned with a rich tapestry of 800 trees and 5,000 shrubs, the towers immediately captured the collective imagination, seamlessly integrating modern living with the serenity of nature. Initially perceived as a bold concept, the Bosco Verticali swiftly captured the hearts of residents and spectators, serving as a sanctuary that not only enhanced the surrounding ecosystem but also reduced CO2 emissions. Boeri's brainchild went on to inspire a global movement of green-clad structures, including iconic landmarks like Jean Nouvel's One Central Park in Sydney and Vincent Calabo's Agora Garden Tower in Taipei. While progress has been made in integrating green roofs, the broader implementation of holistic green surfacing remains in its infancy. Singapore leads the charge, mandating greener integration with new constructions and offering incentives for sustainable practices. Boeri's passion for green architecture transcends time, with projects spanning from Europe to China and Egypt. His vision extends beyond individual structures, encompassing the creation of entire green cities. His next project? The Cancun Smart Forest City. Number 14. MYSE 16.0-242. There was a time when the Minyang Smart Energy, a Chinese wind turbine manufacturer, had the honor of owning the largest wind turbine in the world. The MYSE 16.0-242 is an offshore hybrid drive wind turbine with an almost 800-foot diameter with 390-foot long blades. In all, this behemoth turbine has a 50,000 square foot swept area. This thing can handle quite literally anything, as it's designed for high wind IEC-IB, including Typhoon Class IEC-TC. This turbine is said to have the industry's largest rotor as well as the highest nominal rating. One turbine alone can generate up to 80,000 megawatt hours of electricity over a year, which is enough to power more than 20,000 homes. By comparison, the company's previous turbine model produces 45% less energy, so this is quite a leap forward in wind turbine innovation. It's designed to have a 25-year lifespan, throughout which it can eliminate over 1.6 million tons of carbon dioxide, compared to coal-fired power generation. This wind turbine is the first of Minyang's new 15-megawatt-plus offshore product platform and will be continuing to roll out prototypes and upgrades in the years to come. The company's goal is to develop a range of variants that are adaptable to different offshore environments, from the constantly windy North Sea in Europe to the typhoon-prone South Sea in China. Number 13. The London Crossrail Project. London's Crossrail project is set to revolutionize travel across the UK capital. The highly anticipated Elizabeth Line, also known as Crossrail, will cut the commute between Canary Wharf and Heathrow to just 38 minutes, a significant improvement from the currently lengthy travel times. This 62-mile network of tunnels, a major engineering project, was meticulously crafted beneath London's bustling streets, dodging archaeological remains in the existing underground system. During its peak construction period, Crossrail was the largest engineering project in Europe, employing 8 1,000-ton tunnel boring machines over 3 years. The new railway features spacious platforms and state-of-the-art trains capable of carrying 1,500 passengers at speeds of up to 90 miles an hour. The project incorporates 10 new Crossrail hubs, including new stations with shops, restaurants, and even rooftop gardens, such as the spectacular below-ground Paddington Station. Despite delays and budget overruns, with the final cost estimated at $25 billion, Crossrail is expected to increase London's rail capacity by 10%, marking the most significant expansion of the city's transport network in over 70 years. The project aims to bring an additional 1.5 million people within 45 minutes of central London, significantly improving accessibility for residents and visitors. Moreover, the introduction of the Crossrail will alleviate the strain on existing transport infrastructure, particularly the overcrowded London Underground. With step-free access and enhanced facilities at 31 upgraded stations, the new railway will provide a more convenient and accessible travel experience for passengers. Looking ahead, Crossrail's impact is poised to extend beyond London, as plans are in place to integrate it with the upcoming High Speed 2 project, connecting the capital to the Midlands, the north of England and Scotland. Number 12. The Line Skyscraper Project. Saudi Arabia's most recently proposed mega-project promised to be one of the most ambitious yet. The Middle Eastern Kingdom is gearing up to construct one of the world's largest structures in the desert city of Neom. The structure is expected to span 100 miles in length and will go up to 1,600 feet high. The skyscraper project, named the Mirror Line, is likely to cost an out-of-this-world $1 trillion. The skyscraper will begin from the Gulf of Aqaba to bisect a mountain range that extends alongside the coastline. From there, it'll go on through a mountain resort and complex that will be home to the Saudi Arabian government. The line will pass via an aerotropolis in Saudi Arabia's desert. It is sure to attract people from far and wide with its unique features and Star Trek-esque appearance. The Mirror Line will be designed by US-based Morphosis architects, but so far 9 other design and engineering consultants, including Canada-based WSP Global and New York's Thornton Tomasetti, have also stated that they'll also be part of it. A high-speed rail will run underneath the buildings, connecting every aspect of the city while giving it its own pulse. While the Crown Prince Mohammed bin Salman estimates that the project to be completed by 2030, some engineers believe it could take about half a century to be finished. I guess only time will tell on this one. Number 11. Panama Canal Expansion. The Panama Canal Expansion Project, also known as the Third Set of Locks Project, effectively doubled the capacity of the Panama Canal by adding a new lane of traffic. This extension enabled a greater number of ships to pass through and increased the width and depth of the lanes and locks, allowing larger vessels to transit. The new ships, known as New Panamax, were 1.5 times the previous Panamax size and capable of carrying over twice the amount of cargo. The expansion was completed in 2016 after various setbacks like strikes and disputes over cost overruns pushed the original completion date back. Key elements of the project included the construction of 2 new sets of locks on the Atlantic and Pacific sides, the widening and deepening of existing channels, and the elevation of the maximum operating water level of Gatun Lake. The project was proposed by the then Panamanian President Martín Torrijos in 2006 and was approved in a national referendum in October of the same year. The original aim was to complete the expansion by August of 2014, coinciding with the 100th anniversary of the canal's opening, but multiple delays pushed the completion date to June of 2016. Despite some criticism and concerns about the project's feasibility and steep cost, the Panama Canal Authority insisted on the expansion's profitability and the canal's ability to capture the growing demand in global trade. The expansion's financing, separate from the governmental budget, involved loans from many international global financial institutions. The third set of locks introduced water-saving basins to reduce water usage during lock operations, and the expansion included the construction of navigational channels to connect the new locks with the existing ones on both Atlantic and Pacific sides. Despite initial setbacks, the expansion has significantly increased the canal's capacity, allowing for the transit of larger vessels and accommodating the growing demand in international trade. Number 10. The Shard. Moving around the concrete jungle that is London, it's tough not to notice the Shard. This avant-garde skyscraper, designed by the illustrious architect Renzo Piano, is truly one of a kind and has been turning heads for years. The Shard's design is contemporary architecture at its finest. Its sleek glass-clad exterior soars to a height of over 1,000 feet, making it the tallest building in the United Kingdom and a distinctive presence on the London skyline. Renzo Piano's vision for the Shard was to create a building that would blend seamlessly with its surroundings while pushing the boundaries of architecture. One of the best features of the Shard is without a doubt that glass facade, which appears to transform as it catches the changing light of the day. The use of high-performance glass not only maximizes natural daylight within the building, but also reduces the need for artificial lighting, contributing to sustainability. Its structural design is a masterpiece in its own right. It features a striking, irregular pyramidal shape that tapers as it ascends, giving it a dynamic and futuristic appearance. The building's core is constructed from reinforced concrete, while the facade is a curtain wall of glass panels, providing a stunning 360-degree view. Sure, the Shard is a skyscraper, but it's also a bit of a vertical city. Its 95 stories are divided into multiple zones, including office spaces, luxury residences, a hotel, restaurants, and a public viewing gallery on the 72nd floor, known as the View from the Shard. This multifunctional approach does make it a hub of activity day and night. Its commitment to sustainability is also noteworthy. It incorporates numerous green design elements such as rainwater harvesting, energy-efficient systems, and optimal insulation. The building even has combined heat and power plant, utilizing waste heat to generate electricity, thereby reducing its carbon footprint. Number 9. The Grand Ethiopian Renaissance Dam. The Grand Ethiopian Renaissance Dam is a major hydroelectric project located on the Blue Nile River in Ethiopia. Its primary aim is to address the country's severe energy shortage and enable electricity exports to neighboring nations. With a planned capacity of about 5.15 gigawatts, it will become Africa's largest hydroelectric plant and rank among the top 20 globally. The construction, which began in 2011, has faced financial challenges due to limited international funding, allegedly influenced by Egypt's concerns over the distribution of Nile waters. Originally, the dam design underwent several alterations, impacting both electrical and storage parameters. The initial proposal envisioned 15 generating units with 350 megawatt capacity each, with subsequent revisions resulting in an increased installed capacity of 6,400 megawatts through 16 generating units. The dam's height and reservoir volume have been adjusted over time to accommodate changes in water flow during extreme flood events. The project includes 3 spillways designed to manage floods, while power generation will be facilitated by 2 powerhouses equipped with a mix of 375 megawatt and 400 megawatt turbines, leading to an estimated annual power generation of over 16,000 gigawatt hours. To facilitate the energy distribution, the dam will be connected to the national grid via multiple high-voltage transmission lines, including both 400 kilovolt and 500 kilovolt lines. While concerns have been raised regarding the alleged oversizing of the dam's power output, proponents argue that the increased reservoir volume will provide critical support during droughts, enabling sustained power generation when other small hydroelectric plants may struggle. Ethiopia aims to use the surplus energy domestically, with any excess earmarked for export to neighboring countries such as Sudan, Egypt, and Djibouti, potentially through the construction of a significant transmission infrastructure. The large reservoir volume also opens the possibility of commercial fishing activities and potential tourism development around the reservoir area. Sudan anticipates a reduction in floods due to the dam, although the observed impact is yet to be fully realized. Number 8. The 2nd Avenue Subway. New Yorkers have been talking about it for decades. Many have come and gone since the rumors started, and it can feel as if the only people who will ever enjoy the 2nd Avenue Subway are their great-great-great-grandchildren. The 2nd Avenue Subway is a New York City subway line that runs beneath 2nd Avenue on Manhattan's east side. Now, the initial phase of this project, which included 3 stations on the Upper East Side, opened in 2017. The full 2nd Avenue line, if it secures funding, will be constructed in 3 additional phases, connecting Harlem, 125th Street to Hanover Square in Lower Manhattan. The proposed completed line would span 8.5 miles with 16 stations, accommodating an estimated 560,000 daily riders, at a cost exceeding $17 billion. It was originally proposed in 1920 as a part of an expansion plan for the independent subway system. The construction of the 2nd Avenue Subway led to the demolition of parallel elevated lines along 2nd Avenue and 3rd Avenue in 1942 and 1955. The project faced various setbacks and was temporarily halted in 1975 due to financial constraints during New York City's fiscal crisis. Construction resumed in 2007 with a revised financial plan. The first phase, including the 96th Street, 86th Street, and 72nd Street stations, as well as 1.8 miles of tunnel, cost $4.45 billion. The second phase, covering 1.5 miles from 96th to 125th Streets at an estimated $6 billion, is currently in the planning stages. Ask any New Yorker and they'll tell you that the 2nd Avenue Subway, while insanely expensive, doesn't feel like anything other than a pipe dream. The project has been starting, stopping, starting again, slowing down, coming to a grinding halt, rinse and repeat for over a century now. And even the President of the United States has gotten involved in recent years. Not only is it one of the most massive construction projects, it's also one of the largest endeavors to never be fully completed. Moving on to number 7, Atlanta Falcon Stadium. The Mercedes-Benz Stadium, situated in Atlanta, Georgia, in the United States, was inaugurated in August of 2017, serving as a substitute for the Georgia Dome. It functions as the primary stadium for both the Atlanta Falcons of the NFL and Atlanta United FC of Major League Soccer. The stadium is under the ownership of the state government of Georgia through the Georgia World Congress Center Authority, and it's operated by AMB Group, the parent company of the Falcons and Atlanta United. As of June 2016, the overall construction cost was projected at around $1.6 billion. The stadium's standout feature is its retractable roof, featuring an innovative pinwheel design with 8 translucent triangular panels. These panels operate on 2 parallel rails, facilitating their movement and stabilization. Now, notably, the process of closing the roof is marginally quicker than opening it, owing to specific protocols to disengage the seals and ensure the panel's smooth functioning. The inspiration came from the Roman Pantheon. The roof is composed of a clear, lightweight polymer material capable of adjusting its opacity, effectively regulating the influx of light. Additionally, the extensive use of clear polymer or glass in the exterior design offers panoramic views of the surroundings, including the unobstructed Atlanta skyline, achieved by eliminating the middle concourse and upper bowl in the east end zone. Beneath the roof lies the Halo, a colossal 58 by 1,100-foot video board encircling the rim, spanning an impressive 62,000 square feet. The Halo, manufactured by Daktronics, stands as one of the most expensive display boards in the NFL, surpassing the scale of even the one at Everbank Field in Jacksonville, also erected by Daktronics. Moreover, Daktronics installed over 20,000 square feet of additional LED boards there. Number 6. The Intuit Dome. The Intuit Dome, an upcoming indoor arena in Inglewood, California, is set to become the new home of the Los Angeles Clippers. The groundbreaking ceremony for the new facility was held in 2021, with an expected completed date in 2024, potentially coinciding with the 2024-25 NBA season. Now, earlier, the city of Inglewood inked an exclusive agreement with the Clippers to construct a dedicated basketball arena across from the then under construction SoFi Stadium. The Clippers had previously shared their home arenas with other teams, lacking tangible ownership. The existing agreement with the Crypto.com arena necessitates a process to neutralize Laker branding and achievements before and after each game, highlighting the need for a distinctive arena for the Clippers. Legal disputes, including lawsuits from various groups such as Uplift Inglewood and the Madison Square Garden Company, initially hindered the construction. However, the acquisition of the Forum for $400 million in 2020 by Clippers owner Steve Ballmer marked a significant step forward, eliminating a major obstacle to the construction. The Intuit Dome, designed by AECOM, is planned to accommodate 18,000 seats and will include various amenities such as a practice facility, sports medicine clinic, team offices, and a retail space. Additionally, the facility will have a spacious outdoor plaza with an open basketball court accessible to the public. The arena's design reflects a commitment to creating a modern and inclusive space for both the Clippers and the surrounding community in Inglewood. Number 5. Shanghai Tower. Shanghai Tower, situated in the Pudong district, is a tall skyscraper with 128 floors, making it the tallest building in China and the second tallest in the world. This architectural marvel, owned by the Shanghai municipal government, was completed in 2015, and it's earned the distinction of being the tallest and largest LEED Platinum certified building globally. It's got a bunch of records, such as the world's highest observation deck and the second fastest elevators. Shanghai Tower is a testament to cutting-edge engineering. Planning for the tower started in 1993. As part of a financial district development, construction work officially began in November of 2008, with Shanghai Construction Group overseeing the project. The tower's core was constructed using a repetitive slip forming process, reaching a height of 1,109 feet by September of 2012, and surpassing the heights of neighboring super-tall skyscrapers like the Jinmao Tower and the Shanghai World Financial Center. The construction of the tower was marked by several milestones, including the laying of the final structural beam in August of 2013, symbolizing the tower's topping out. The building's interior and electrical fitting out were completed in late 2014, and it gradually opened to the public over the following months. Now, despite its engineering feats, the tower faced challenges in attracting tenants initially, leading to delayed occupancy permits. However, significant progress has been made since then, with notable organizations like Alibaba, Intesa Sanpaolo, and Albright Law offices leasing space within the tower. In 2021, the J Hotel Shanghai Tower opened its doors, adding another dimension to the tower's multifaceted design. It was designed by the American firm Gensler and led by architect Jun Jia. The Shanghai Tower stands out for its unique double-layered facade, which facilitates ample natural light without compromising the building's energy efficiency. The tower's vertical transportation system, designed by Edgett Williams Consulting Group, is a key feature, enabling access to its numerous facilities and amenities. Moreover, the tower's innovative tuned mass damper plays a crucial role in minimizing swaying at its peak. Number 4. The Three Gorges Dam. The history of the Three Gorges Dam, the largest hydroelectric dam the world has ever seen, is a story that spans several decades. The idea for a dam on the Yangtze River in China can be traced back to the early 20th century. The vision for a dam gained momentum in the 1950s when Chinese leader Mao Zedong expressed his support for such a project, not only as a means for generating electricity, but as a way to manage the flooding of the river as well. However, it wasn't until the 1980s that serious discussions and studies began, assessing the feasibility and potential impact of the construction. In 1992, the Chinese government officially approved the Three Gorges Dam project, and ground was broken in 1994. Now, the building process was a massive undertaking, involving the relocation of over 1 million people, the flooding of numerous villages and archaeological sites, and the erection of one of the largest concrete structures in the world. The dam was constructed in 3 main stages. The first stage involved building a coffer dam to redirect the Yangtze River's flow, allowing the construction of the main dam and power plant. The second stage focused on the construction of the main dam structure, while the third stage involved the installation of power generating equipment. The dam itself, along with its associated structures, required approximately 27 million cubic meters of concrete. Now, to put that number into perspective, it's estimated that the amount of concrete used in this construction was enough to build a 13-foot wide sidewalk that could wrap around the Earth's equator more than 4 times. This colossal structure stretches approximately 7,600 feet in length and stands 607 feet tall. Not only is it the largest hydroelectric dam in the world, but it also holds the distinction of being the world's largest hydroelectric power station in terms of installed capacity. The dam has 34 generator units capable of producing approximately 100 billion kilowatt-hours of electricity annually. The estimated cost of the project was around $28 billion, making it one of the most expensive engineering ventures in history. Number 3. The Seikon Tunnel. The Seikon Tunnel, with a total length of 33.4 miles, is a dual-gauge railway tunnel in Japan, with a 14.5-mile section under the seabed of the Tsugaru Strait. It serves as a critical connection between the Aomori Prefecture on Honshu and the northern island of Hokkaido. The tunnel, part of the standard-gauge Hokkaido Shinkansen and the narrow-gauge Kaikyo lines, lies about 330 feet below the seabed and 790 feet below sea level. Its name, Seikon, originates from a combination of the nearest major cities on both sides of the strait, Aomori and Hakodate. The Seikon Tunnel boasts the title of the world's longest undersea tunnel by overall length and the second deepest transport tunnel below sea. Construction of the tunnel commenced in 1971, and after overcoming numerous technical challenges and an arduous construction process, it was officially opened in 1988. The geological conditions posed significant difficulties, with the tunnel passing through volcanic rock, pyroclastic rock, and sedimentary rock of the Neogene period. Now, initially, the project's necessity was questioned due to fluctuations in traffic predictions, but its completion facilitated railway transport between Honshu and Hokkaido. However, despite its significance, the majority of passengers continue to favor air travel due to speed and cost advantages. The Seikon Tunnel has also accommodated the Hokotuse and Cassiopeia overnight train services, which have since been replaced by the Hokkaido Shinkansen. The tunnel's construction involved the excavation of 3 bores, including a pilot tunnel, service tunnel, and a main tunnel, with periodic connections at intervals. It also has advanced safety measures such as emergency escape points and stations equipped with exhaust fans, fire alarm systems, and water spray nozzles. The tunnel's legacy includes its role in supporting economic development and cultural exchange between Honshu and Hokkaido, as well as its contribution to the overall advancement of Japan's transportation infrastructure. With plans for further expansion of the Shinkansen network through the tunnel, the Seikon Tunnel continues to be a crucial component of Japan's modern railway system. Number 2. Al Maktoum International Airport. Al Maktoum International Airport, commonly known as Dubai World Central, is an expansive airport situated in Jebel Ali, approximately 23 miles to the southwest of Dubai in the United Arab Emirates. Commencing operations on June 27, 2010, the airport forms an integral part of Dubai South, an extensive planned development encompassing residential, commercial, and logistical components. Projected to cover a sprawling area of 35,000 acres, the airport's full completion, initially set for 2027 and now expected in 2030, envisions a comprehensive infrastructure supporting various transport modes, logistics, and value-added services, including manufacturing and assembly, all within a single free economic zone. It's estimated to handle up to 12 million tons of freight and accommodate between 160 and 260 million passengers annually. During the initial stages, the airport was designed to handle 200,000 tons of cargo yearly, with the potential to expand to 800,000 tons. The passenger terminal, initially set to cater to 5 million passengers annually, aimed to become the world's most significant cargo airport, with a projected throughput of 12 million tons by 2013. However, global financial crises and subsequent delays pushed the completion date to 2027. Operational highlights include the certification to accommodate passenger aircraft with up to 600 passengers in February of 2011, followed by the commencement of passenger flights in October of 2013, with carriers such as Nazair, Wizz Air serving the airport. By early 2016, the airport witnessed a substantial increase in passenger numbers, reaching over 400,000 in the first half of the year. Anticipated expansion plans include the construction of 6 runways, multiple passenger terminals, executive and royal jet centers, hotels, shopping malls, and various support and maintenance facilities. The airport is expected to be connected to the existing Dubai International Airport through the proposed Hyperloop and high-speed rail systems, as well as the Dubai Metro and a dedicated Dubai World Central Light Railway. Additionally, the incorporation of large warehouses and hangars along the airport's western perimeter, capable of housing A380 aircraft, is part of the comprehensive development plan. With a proposed link to the Expo City neighborhood by road, Al Maktoum International Airport is positioned to be a vital transportation hub, catering to diverse travel and logistics needs. Number 1. The South-North Water Transfer Project. This project is a colossal infrastructure initiative in China aimed at diverting an immense 11 cubic miles of fresh water annually from the Yangtze River in the south to the drier, industrialized north. The project comprises 3 extensive canal systems named Eastern, Central, and Western routes, designed to facilitate this ambitious transfer. The project was first discussed by Mao Zedong in 1952, with construction commencing in 2003. By 2014, a staggering $79 billion had already been spent, underscoring the project's massive scale and price tag. The eastern route involves upgrading the Grand Canal and establishing a pumping station in Jiangdu to draw water from the Yangtze River. Now, despite facing construction delays and challenges related to water pollution, the route has successfully diverted water to Shandong and Tianjin. The completed line spans over 700 miles, equipped with 23 pumping stations. On the other hand, the central route, known as the Grand Aqueduct, extends from the Jiangjiangkou Reservoir to Beijing, overcoming the engineering hurdle of tunneling under the Yellow River. Now, despite concerns about the project's impact on the Han River and the resettlement of hundreds of thousands of residents, the completed Grand Aqueduct spans approximately 785 miles, transferring nearly 3 cubic miles of water annually. There are also plans for the western route, aiming to divert water from several rivers in southwestern China to the Yangtze and Yellow Rivers, ultimately catering to the water demands of northern China. The magnitude and cost of this proposal have raised significant concerns, particularly regarding potential environmental impacts. With the scale and cost of the project far exceeding initial estimates, the South-North Water Transfer Project has sparked controversy and criticism, primarily due to environmental concerns, the displacement of local communities, and potential water loss through evaporation. Despite these challenges, the project represents a monumental engineering endeavor in addressing China's water distribution challenges. I'll see you guys next time. Watch our binge-watching playlist if you'd like to watch all of our most popular top 15 videos. Grab a drink, grab a snack, and get ready to binge. Thank you to our channel members.